You know, if you're gonna live in your rig full time, the difference between a good rig and a great rig and a rig that'll kill you and a rig that'll protect you can come down to one thing, and that's the insulation you choose. Whether it's foam board, Reflectix, spray foam, or some other type of formaldulate, what you choose to put in the walls of your bus is a situation that you only get control of once, and you gotta get it right. I'll tell you, over the last 8 years that I've been building buses, we've tried a lot of different methods and we've landed on some things that really work. And in today's video, I'm gonna explain those methods to you, educate you on how you can choose what's gonna work best for you, and even get philosophical where we decide our approach to how we'll insulate our rig. My name's Chuck Cassidy. Don't go anywhere because this week's video is an important topic that affects everybody. Let's talk about insulation. Before we go too far, I want to cover a little bit of the syllabus for today's coursework. We're going to start Insulation 101 with an introductory to insulation philosophy. We'll move from that to understanding the physical principles and the types of energy or heat transfer that happen in our lives so that we can understand then what types of insulation we want to use to address those different types of energy transfer. After that, I'm going to hop on the soapbox for an excellent dissertation about the truth about Havelock wool, including some information about their product that they go out of their way to make hard to find. Then I'll get into a company called Hushmat and go over their own brand of disinformation and provide some clarity around radiant barriers. Lastly, I'll wrap it up with some installation guidelines covering topics like thermal bridging, how to choose what thickness you want, and even how framing will affect the effectiveness of your insulation system. Let's go ahead and dive in though and get started talking about the philosophy of insulation. There are a lot of ways to approach insulating your school bus or whatever rig you're working on, and all of those will reflect some type of philosophy that you've adopted regarding your approach. For me, I've enjoyed many different philosophies about how I insulate a rig. From the first bus I lived in 2006, where I ran with the stock insulation that was already in the walls of the bus, and I just dealt with the consequences therein and never really considered that life could be better as I was sweating out the summer heat and freezing in the winter. The next bus I did a few years later, I went a little out of my way to try and do it right, you know. I put in some Reflectix in the floor, total waste of money, and even went out of my way to put in some expanded polystyrene insulation in the walls, which is also a waste of time and money. It wasn't until my third bus when I realized that spray foam, closed cell type, was going to be the best insulation for me and my goals, and I went with that, and in fact, that's what we've been running here at Chrome Yellow ever since. That might not be the right choice for you, but each one of those illustrates how my philosophy toward insulation changed over the years as my awareness around what I was living with and what my options were grew. So let's go ahead and dive into the philosophical aspect of this and talk about how your values and priorities will help shape the insulation that you choose. Well, it's no secret that around here, our insulation of choice for the walls and ceilings is closed cell polyurethane spray foam. A lot of folks choose to avoid this type of insulation because they're afraid of its chemical composition and the potential for off-gassing. And I understand those and I believe they're valid concerns. However, for me and my own values and priorities, that's a great insulation for what I'm trying to do. In my eyes, the potential for mold and other issues caused by using different types of insulation offset any potential, whether real or imagined, that the off-gassing of the closed cell polyurethane spray foam will actually be a problem. After all, I'm choosing to live inside a diesel-powered vehicle, making regular trips down the highway, breathing air that is coming fresh out of the tailpipes of the thousands of cars in front of me. But I digress. This is your vehicle, your build, you do as you choose, and in today's video, my goal is to be as objective as possible while presenting my own opinions and giving you the space to make your own choices based on what will work for you. Let's assume that you're one of those people who wants to avoid spray foam insulation, and so you're looking at other alternatives. That's a perfectly reasonable thing to do. And I think these other alternatives can be very viable, especially if your values and priorities place the pros over the cons for that specific type of insulation against other types of insulation. If you're looking for something that's all natural, you don't want to use polyurethane spray foam for whatever reason, it's just important to understand that with those types of insulation come trade-offs. The worst thing that could ever happen is where you make a decision unaware of the trade-offs that you're making, only to find out later that had you had more information, you would have chosen differently. My intention with this video is to make sure you never end up in that position. So the first thing we have to decide when we're taking a look at what insulation we're going to put in our rig is what are our values and priorities around the materials and performance associated with our insulation. The next point of our discussion is going to be improving our understanding of the physical principles and properties of heat and how heat moves through our build and its movement through our build can be contained. For our purposes, there are three main types of heat transfer or energy transfer that we need to worry about. The first one is going to be radiation. The second one will be convection, and the third will be conduction. Let's go ahead and dive into radiation or radiant heat energy transmission. This happens anytime you have a warm object. If you point an infrared camera at something, you are observing its infrared radiation. And infrared radiation is exactly the kind of energy that radiant barriers are meant to address or prevent the transmission of. Let's take a look at some practical examples. Say you walk out into the sun and you feel that warm sun shining down on your face. That is 100% radiant energy hitting you. If you take a piece of shiny aluminum foil that's big enough and put it in front of you and reflect that sun's energy away from you, you will be blocking all of that radiant energy that's coming towards you. Now, a lot of times insulation manufacturers will use the properties of some material, say aluminum, to reflect energy back and then equate that into an R value rating. And this can lead to some very confusing information out there about the R values of different types of radiant barriers. One great example is this product here. This is Reflectix, and actually it's something I really love, but you have to know how to use it. As you can see, it's got a shiny side, two of them in fact, and in the middle it's got this foam. And the foam actually acts as kind of a decent conductive barrier, but really what we want to look at are its radiant properties. So I've got a bright light over here, and let's assume that's a heat lamp. If I put this between the heat lamp and me, it's going to block all of that energy from hitting me. That's awesome. That's going to be performing really high, and it's going to give the impression of a high R value. Now let's change this light that's in front of me, and let's turn that light into, let's just say simply a hot pad. If I take that hot pad and press that against this piece of Reflectix in my body, that hot pad's heat will be felt by my skin underneath this Reflectix. And that's because the Reflectix doesn't have an air gap or any ability to reflect that heat out, the radiation coming off of it. Instead, it's relying solely on its properties as a conductive insulator, which are not that great because it's not very thick. The next type of heat transmission I want to talk about is through a process called convection. And this one is pretty simple. I think we all have a decent understanding about that. It's kind of how hot air balloons work to a certain point. Convection is the idea that hot things, hot air in specific, has a tendency to rise as it heats up, and it will take the heat that it has and distribute it upwards. If we wanted to slow down convection or prevent it, the obvious thing to do is stop the flow of air. And a lot of times things like air barriers are designed just to do that. If you are in, the conventional home construction world, the use of air barriers and air sealing is an important component of insulating, especially when you're trying to insulate an attic. But luckily for us in a school bus, because we are starting with what is hopefully a sealed-in shell, one that's not that important. The third type of thermal energy transfer, and in my opinion the one that's most important for most people designing a school bus or a van conversion or any old rig to live in, is that of conduction. Conduction is what happens when you have a material and another material separated by an insulator or a conductor, and because one side is hotter than the other, you will have energy that wants to flow through that conductor or that insulator. The best insulators will prevent the flow of that energy, and we'll call it heat because that's what it is, from one side of the surface into the other. Now, let's take a look at a school bus. A school bus is essentially a metal shell, okay? That's one surface. And then we have our interior finished surfaces, like our floors and our walls and our ceiling, and that's the other surface. And in between them is our insulation. You can understand now why, because we're talking about conductive heat flow, that the insulation we choose to put in our floors, walls, and ceilings really need to have outstanding conductive insulating properties. And that makes a perfect segue into the next portion of this video, where we're going to talk about the different types of insulators out there and how they perform and what they work best at. Now, I know we talked about this briefly earlier, but radiation is where we'll start. And in my opinion, there is almost nothing better than this Reflectix material for providing excellent insulation against radiative sources of energy, heat. If you put this in your window, and this stuff, it comes in 4-foot rolls, it's great, you can cut it to fit, and pop these in your windows in the summer, you'll be preventing 100% of the sun's radiation from getting in through those windows and reflecting that heat back out of the bus. That's a great application for this material. Similarly, if you're going to be insulating your bus and say you want to keep heat from the hot engine bay from making its way into the bus through your firewall, that's when a product like this, which is basically a sister to Hushmat, works excellent. The shiny side will face the heat source, which is your engine, and you will seal it up against your firewall, and it will reflect that hot infrared radiation off of your engine back into the engine bay instead of letting it get into your living space. What's interesting here is, and I'll go ahead and post a clip, there are manufacturers out there who make these two kinds of radiant barriers that I described, the Reflectix type insulation and also the more automotive type Hushmat or Killmat. And they both take different approaches toward advertising their R values. I think this alone explains a lot. If you look at this site that I'm showing you now, this is from a company who makes radiant barriers for use in attics. And as you'll notice, they go out of their way to explain how to best use their product and achieve the highest R value, while pointing out certain installations where that R value won't be reached. I really appreciate that, because they're informing you how to use their product to the best and not trying to sucker you into buying something advertised as R22 when really it's more like R.2 if you sandwich it in a floor. There are other approaches to this adopted by companies like Hushmat and others that I'm going to get to in a second, but it's much more deceptive. For managing convective heat transfer, I think you can probably put your concerns about convection at bay simply by making sure that you don't have a drafty bus. The final type of energy transfer that I want to talk about is conduction, which is the most important and the insulations that I like most for dealing with that. And in my view, there's almost no substitute and nothing better than foam. And there are lots of types of foam out there, and I want to touch briefly on 3 or 4 of the most common types and go over their properties, starting with this, which is what we install in our subfloors. This is extruded polystyrene, XPS, not to be confused with expanded polystyrene. Expanded polystyrene is the kind of styrofoam that you'll see that's made up of all those little white balls. And it's a fine product in a lot of applications, but it has a lower R value than XPS, and it also lacks the compressive strength that XPS has. And it's because of this compressive strength that we like to use XPS, extruded polystyrene, in our subfloors, in our full floating subfloor assemblies. We don't frame our subfloors. We install our 3/4 inch tongue and groove Advantech OSB type subfloor directly on top of the XPS, which is in turn directly on top of the metal floor pan. Because this has a compressive strength of 25 psi or 15 psi at minimum, that is more than enough to handle the loads of not only everyday foot traffic inside your bus when it's underneath that 3/4 inch subfloor, but even the weight of the bus yourself. And if you don't believe me, check out a video I made where me and my colleague Ben put that to the test and dropped the full weight of 1/2 of my rear axle on a piece of XPS foam with 3/4 inch plywood on it and saw no deformation whatsoever. One other type of foam board insulation I want to quickly touch on is polyiso. Polyiso or polyisocyanurate, this type of insulation has the unique characteristic of having an R value that actually drops as the temperature goes down. In fact, it drops so precipitously that at around 20 degrees Fahrenheit, it's hit the same R value per inch as this XPS foam. And if we're talking about floors, when does the R value of your floor system matter most? That's when the temperatures drop. So that's why we choose XPS over polyiso foam board in our floors. If you're looking for in-floor insulation, polyiso is absolutely not the way to go. Of course, my next most favorite type of insulation is going to be the DIY spray foam insulation that you get from these big kits here. And there's actually 2 of these containers connected to a hose, and they spray out of a gun like this. And if you can't find a contractor to do the work for you, or if your job is too small, they're a great way to go. It's about $800 for 600 board feet. And as long as you follow the directions properly, you'll get great results. Are they as good as a professional spray rig? No. As long as you ensure that the chemicals are properly mixed, you're getting a full cure with good adhesion, you can't go too wrong, and you're gonna get the high R value benefits of spray foam. Around here, whenever we have the opportunity to, we like to hire professionals to come in and do our spray foam insulation. In fact, a lot of times it ends up being cheaper than if we were to do it ourselves, simply because the price of their product is so much lower than anything even we can get as installers, at least around here. The advantages of spray foam insulation are threefold, in my opinion. The first one is you get a high R value that fills all the nooks and crannies. The next one is if you go to a thickness, depending on who you ask, between 1 and 2 inches, you pick up all the benefits of a vapor barrier, sealing off the underlying surface from ever coming into contact with hot, moist air inside your living space, which might otherwise condense on the cold external skin of your living structure, in our case a bus, and turn into water, fill your wall cavities with moisture, and cause conditions that are favorable or prone for mold, rust, and mildew. The last thing that I really love about closed cell spray foam, especially in a bus, is that it adds a lot of structural rigidity to the overall wall structure. When that whole wall cavity is filled in with closed cell spray foam, it really locks that framing in place. It reduces all the vibrations, any of the humming that happens. It eliminates, in my opinion, the need to install types of insulation like this kill mat here to absorb sound and prevent resonant frequencies from, vibrating around your bus. And it's a great choice, in my opinion, the best choice for managing the conduction of heat through your wall system. I would be remiss, however, if I didn't talk about another type of insulation, which is batt type insulation. Batt style insulation, it's everything from those big fiberglass rolls to the products sold by Havelock or Rockwool or even the hemp brand. There's tons of different batt style insulations out there on the market, and it's important that when you make comparisons between spray foam or other types of foam-based insulation and batt style insulation, that you understand the trade-offs and additional complexities introduced when you move to an insulation type that doesn't have built-in vapor barrier properties. I will choose to take a look for now at Havelock wool for this purpose. Havelock wool is something that's really popular. They spend a lot of money making sure that influencers are using Havelock wool and that we're all aware that they're choosing that. But they don't cover some important aspects that you need to consider if you're choosing Havelock wool for your build. The first one is that Havelock wool and all wools are very flexible, and they're a type of lightweight insulation that doesn't easily hold its own shape. And that might be fine in a conventional home, but if you're building a bus that's going to be traveling down the road, going over bumps and washboard dirt roads, unless you very securely affix that insulation in your stud bay or wall cavity, there's a very good chance that 20,000 miles after you install it, all your insulation is going to be at the bottom of that wall cavity. The other thing you have to consider if you're going to be using Havelock wool or any other type of batt style insulation is how you will manage vapor in your wall cavities. A vapor barrier is something that is hotly discussed in the building science communities, but if you're choosing to live in a metal structure that you're insulating with batt style insulation, I think a consensus would be that the best choice that you could do for yourself is going to use what's called a variable vapor barrier or an intelligent vapor barrier. It's also known as a one-way vapor barrier. And what it does is it prevents the warm, moist air inside your living space from getting into your wall cavities where it could then come in contact with the cold steel skin of your bus. As we all know, hot, moist air coming into contact with a cold surface will create condensation. The condensation can lead to mold and rust and all kinds of problems, and so we have to stop that. And these vapor barriers, or variable vapor barriers, aim to do that by preventing that air from ever coming into the wall. Another thing they do that's very important is they make sure that any vapor that gets into that wall is able to come out by essentially acting like a one-way valve that stops vapor from coming in and lets vapor that did get in get out. If you're going to be doing an insulation system like that, that you make sure that over the course of a winter you are getting enough heat in that internal living space long enough so that your walls have an opportunity to dry out. If you're only getting it warm enough to just barely stay comfortable but not raise the dew point of the interior air high enough so that it can absorb that moisture out of the walls, that moisture is just going to simply collect in the walls and create lots of problems. And that, my friends, is going to lead me into this week's soapbox. Aside from being a natural product, I think one of the biggest selling points that Havelock Wool relies upon, in addition to their influencer marketing, is the promise that Havelock Wool is able to intelligently monitor and manage the moisture in your wall system. While I understand that wool does have those properties, I love wool sweaters and wool socks exactly for that reason. I feel that those claims are overblown to the point where if you're relying on them in a steel-based structure, you're going to be really shooting yourself in the foot and opening your build up to the possibilities for mold, rust, and mildew unless you go to the great lengths of installing a vapor barrier, something that Havelock Wool claims isn't necessary when you're using their product. The interesting thing is, if you scroll to the bottom of their website, they have a special page titled Vapor Barrier where you link over to a blog post where they acknowledge that in certain, nay, many types of builds, especially those that participate in varying climatic conditions, like a school bus, will benefit greatly from using a vapor barrier even with their wool insulation. And I can paint a picture that explains it very clearly why this is true. If you are living in your bus in a cold climate, and let's say every day you get home from work and you take a shower and you cook a meal on a propane range, and let's just say that there's 2 of you living in the bus that do that. Well, those activities will generate a lot of moisture, not just through breathing and taking a shower, but anytime you burn propane or any other hydrocarbon fuel, one of the byproducts is always water, especially if you're boiling a pot of water, making a soup. You introduce all this moisture into the interior air of the bus and you raise the relative humidity high enough, you raise the dew point of the air inside of your bus that it lines up with the temperature of the skin on the outside of your bus. And if that warm, moist air happens to come in contact with the skin of your bus whose temperature is below your high dew point interior air, it leads to condensation. If every day during the middle of a day the indoor air temperatures are not getting high enough to drop the relative humidity inside the bus enough to allow that air to absorb moisture out of your walls, we're now in a situation where every day a little bit more moisture ends up in the walls than the day before because the walls don't have the ability to manage that. Wool can only absorb so much moisture, am I right? If you get a wool sock and soak it in a bucket, you can't just keep dunking it and get more moisture in there every time. The same thing's happening in your walls. So if you don't go to the lengths of installing a variable vapor barrier that's going to prevent that moisture from getting into your walls in the first place, you find yourself in a situation, in circumstances that are not that hard to imagine being very common for us, where your walls will become filled with moisture. And Havelock Wool, they do eventually admit that in a lot of installations, especially those that are a school bus, use of a variable vapor barrier becomes essential. Havelock, I really don't like that you go out of your way to design your marketing campaigns to hide this fact. It's not honest marketing, and anytime a company engages in that, I ask, what are they trying to hide? Keep in mind, Havelock Wool puts insulation out there for influencers to use all the time. They go out of their way to build hype around their product, while spray foam companies do not. When was the last time you saw somebody's build or their insulation sponsored by a spray foam company. You haven't because it's not an issue. In fact, spray foam was used by Bluebird when they did their Wander Lodge series of RVs dating back to the early 80s. And I've had the opportunity to cut into those, and I've seen no issues with that spray foam even being 40 years old. I'll get off my soapbox on that issue, but don't worry, there's another one coming right up. So a few weeks ago, another influencer out there on the YouTubes had found a product called Hushmat and was touting its high R value as a perfect replacement for our beloved foam in the floor system of your bus to achieve an R value of 7 and only about 1/8 of an inch. Immediately, my BS detectors were just going off the charts, so naturally, I had to reach out to the company themselves, Hushmat, where I immediately was replied to by the CEO, which is a little strange, who then went out of his way to illustrate that he does not have the technical understanding to defend his company's claims of an R value of 7 in all installations. Let's fall back on the information we were talking about earlier about radiant barriers, how they perform, and how they can deliver such high R values in such thin thicknesses. We all know that is because radiant heat coming at us can be reflected back by a barrier that is very thin. It could simply be a shiny piece of aluminum. And so if we can imagine a hot engine bay like we talked about earlier, by placing our Hushmat up against the firewall with the shiny side facing the engine, we're going to stop a lot of that radiant heat from getting onto the firewall. In that circumstance, sure, it's an R value of 7, but when I asked him whether or not if I put this between the metal floor pan of a bus and the plywood subfloor, he said that again, it would deliver an R value of 7. Now that goes against everything I know because the R value of aluminum and butyl rubber, which is what that is, don't buy into their marketing hype. It's nothing new, okay? They're saying it's proprietary and perhaps it is, but they even say on their site in the product description that it is still a butyl-based product. Well, the R value of those things together is going to be under 0.4 per inch of thickness. So there's just no way that we're going to see their claimed R value of 7 out of just 1/8 of an inch of thickness. But to follow up on this, I kind of set a trap and asked him, hey, if one layer gets me an R value of 7 per inch, then wouldn't 2 layers get me an R value of 14? To which he responded, well, no, you're not going to see that. In fact, you're going to see a lot less. You're going to see an additional R value gain in the teens of percent instead of 100%. And to me, that goes against everything that we know about the properties of thermal conductive insulators, like this foam here. This foam has an R value of about 5 per inch. And the nice thing about that is if you go 2 inches, that means you have an R value of R10. That's because it is a thermal insulator, okay? It stops the transmission of energy between two surfaces. That's what we need in our subfloor. We're not worried about radiation because the radiant energy is already being absorbed by the metal floor pan of the bus. At that point, it's turned into heat energy, and then it's only going to be conducted. So when he said that the addition of a second layer is not good for a linear increase in its R value, we immediately know that its claimed R values and insulation performance is not reflective, pardon the pun, of its ability to be a conductive insulator, but rather it's all contingent upon its ability to be a reflective or radiant insulator. So dear Hushmat, I am hereby notifying you that I'm hip to your BS and that your product should never be used if you're trying to get an R value of 7 between the plywood of a bus and the metal floor pan. Your money is better spent doing nothing than spending all of that money on Hushmat. It's something like $400 for 50 square feet of it. Keep that in mind the next time you're taking someone's advice on the internet. And with that, I will get off of my soapbox and we can resume our discussion how to design our bus and the insulation that we'll be installing in it to get the most bang for our buck and bang for every inch of thickness from whatever product we choose to install. Now, when it comes to maximizing your insulation's performance, one thing that we have to talk about is thermal bridging. In general, thermal bridging is what happens if you can imagine a wall where, say, we've got an R value of 20 and then we have a stud, and that stud being made of wood has an R value of 1 per inch, and let's say it's 3 inches. So we have R20, R20, and then R3, and then R20, R20, and then R3. At each one of those points, we have what's called a thermal bridge, and that is essentially a bridge where thermal energy can pass a lot more freely than it can through our insulated wall system. With that in mind, thermal bridging is something that we really have to pay attention to. Additionally, we have the worry of vapor barriers and how we're going to deal with whatever moisture that's trying to get into the walls to make sure it never hits a surface where it will condense out of the wall and turn into moisture. That's where we really have problems. There are countless videos out there of people who have framed their walls by sistering or attaching to the side wood studs along their ribs. And they do that so that their walls don't get any thicker and their ceiling doesn't come down any farther than it absolutely has to. And they'll go back in and insulate. You can use any insulation you want, but if you are sistering those studs up completely against the steel, you're creating a perfect thermal bridge from that steel into the wood, where the R value of that wall system is going to be very, very diminished. Furthermore, if you go with a system like that, and let's say you go in spray foam. Now you might be patting yourself on the back thinking, hey, I did a great job, you know. I used spray foam and I put my wood in so I don't have a thermal bridge. Well, as I just said, you have that thermal bridge because it's attached to the metal ribs of your bus. And because you did spray foam everywhere else, that means any moisture that would otherwise go to that part of the wall and condense out isn't going to happen. But what is going to happen is that moist air is going to find every single rib, because keep in mind, you framed out so that you're flush with the rib. It's going to find every single rib, it's going to condense on that rib, and you're going to have a ceiling that drips and appears to be leaky, when in reality, it's simply the moisture from the air inside your bus, which could be from your breath or cooking or showers, condensing on those cold ribs and coming down on you. And that's a real issue. And I've got videos that I'll show illustrating this. And you can see here, this is a build done by a woman who had the courage to actually share with other people how her insulation and framing method failed her. And this is a method I've seen by lots of other people who claim to be pro builders out there. The truth is, if you're using spray foam insulation, and you don't go over your ribs to a thickness of 1 to 2 inches and pick up that vapor barrier property, you're just wasting your money, and you're going to have a situation where your cold ribs will be perspiring and condensing moisture out of the air and filling your walls with water. The last thing we want. But that's not spray foam's fault, that's your fault for framing and installing a badly designed wall system that doesn't leave adequate room for the insulation you're installing to do its job. Another quick thing I want to touch on while we're on the subject of this is an approach or a question that people often ask me when they see my framing method. We have the vertical steel ribs and I screw my wooden strapping directly to that. And a lot of people freak out because they say, hey, you've got wood touching steel, and isn't that going to cause moisture to get in there from the condensation of warm air hitting the steel? And that would be true if that joint or that connection was happening out in the middle of the bus. But it's not. In our wall systems, we frame in like that and then spray over that whole assembly with 1.5 inches of spray foam so that that rib is completely covered. Warm, moist air will never get to that connection point between the wood and the metal, and you're not going to have any issues of condensation or moisture happening there, causing the wood to rot or the metal to rust. It doesn't work that way. I've seen people take sill plate gasket and install it there, thinking, and I understand, you know, kind of the intuitive idea behind that, or the intuitive reasoning, if that's not an oxymoron, why people think that's a good idea. You know, don't let the wood touch the metal and you're fine. That's not the issue. The issue is don't let the warm, moist air touch the metal. It doesn't matter if the wood's touching the metal. We don't want the warm, moist air touching the metal. Sill plate gasket was never invented or used as a way to keep the cold cement of a foundation from conducting up through into the bottom sill plate of a framed structure. It was actually there because the top of a foundation wall, if you ever look at it, is not flat and it's not smooth. And when you bolt your sill plate to it, there's always going to be little gaps in there, and those gaps offer opportunities for bugs and air to ingress into your house, and that's what a sill plate gasket is blocking. If you want to install it under your strapping, by all means, be my guest, but it's not going to net you any measurable benefit, especially if you're already going to be spray foaming out 1.5 inches on top of your ribs because you're framing out 1.5 inches. That's the best way to prevent any type of moisture issues from happening where the wood of your framing or strapping meets the steel frame of your bus. So if I haven't made it clear already, the most important thing to keep in mind when you're insulating your bus with regards to moisture management and vapor barriers is to make sure that you have no bare steel exposed to the warm, moist air of your living space. If that means spraying 1.5 inches of spray foam over all of your ribs in addition to the 1.5 inches of the depth of the ribs, so you have a wall cavity with a net thickness of 3 inches, then do that. If that means using your Havelock wool and coming back in with a variable vapor barrier afterwards, then do that. If that means using rigid foam board and coming back in with great stuff and filling the gaps, then do that. But you have to do everything you can, if you don't want moisture in your walls, to keep that warm, moist air from contacting the cold exterior skin of your bus. While we're on this topic, I want to briefly touch on something that has to do with windows. Now, even the windows behind me, being the double pane RV windows that they are, doesn't mean that there won't be times where they get condensation on the inside of them. And you know what, for me, that's not something I'm worried about because these windows actually have drains built into them to drain that moisture to the outside of the bus. If you're somebody who foolishly decides to keep their stock windows, you can do everything in the world to seal those windows completely to the outside world, and you might even be 100% effective at that. Those windows might be completely watertight from the outside. You're going to run into serious problems though if you're ever in a situation where, again, you have warm, moist air inside your bus contacting the cold surface of your windows, creating condensation on your windows that then will drain down, and because stock school bus windows do not have a drain to the outside world, and it will drip down the windows into your walls, and if you're lucky, a few months later you'll find some mushrooms growing out. If you're not, you might find some mold, or worse, you might feel the effects of mold and then have to go hunting for it. That's one more reason why you will never see me recommend or use stock school bus windows in a build that is designed to be lived in full time in all 4 seasons. Well, we're just about done talking about the different methods of insulation, but before we do, I want to mention one important thing, which is how we manage the air exchange inside our bus. The current state of the arts in the building science world is that you want to seal the structure up as much as you can so that you can manage how it breathes. That's the camp I reside in, and that's the camp I would suggest you reside in as well. A lot of people out there were talking about the importance of building structures and vehicles that breathe, and I agree with them, but I don't want that breathing to be happening in my walls. The less air exchange I have happening between the inside of my bus and the wall cavity, in my opinion, the better. That's where, if I haven't made it clear, most of the problems will start. When your warm, moist interior air goes into your cold wall cavities and the moisture condenses out. With that in mind, my favorite method for dealing with this is to build an airtight rig and then incorporate venting methods that give you control over how and when the air is exchanged inside your bus. The easiest thing you can do is open some windows. Things get more advanced when you talk about the addition of powered roof vents up on top of your rig, which I don't understand how people live without. And there are also options out there like energy recovering ventilators or heat exchangers where they will mix the air coming into your bus with the air exiting your bus so that you don't have a cold or a hot draft, but you still get the air changeover that you want to have so that the interior air inside your rig smells good, feels good, and doesn't pick up too much indoor moisture. Well, I think that's going to do it for my discussion on insulating your skoolie, but if you like this type of content, make sure you hit that subscribe button. My name's Chuck Cassidy, and I've been doing this for 8 years, and my mission with these videos is to pass on the knowledge I've gained so that you can learn from my mistakes and not make them yourself. We'll see you here next week.